We are now in Unit 4 of the Introduction to Microeconomics. I'm your host, Elias. In this video, I want to take you through the opportunity cost and the trade-off. So we will look at the graphical illustration of opportunity cost, as well as some of the possibilities of expansion in production where we'll have the growth. Okay, so let me quickly take you through the outline. So we'll look at the production possibility curves or the production possibility frontier, which before doing, probably we'll have to look at the assumptions that are used in coming up with a graph, and then we'll look at the efficient, the inefficient, and beyond possibilities. Then we'll look at the marginal rate of transformation, which is the slope of the production possibility frontier. And then finally, we will look at the constant and the increasing opportunity cost. So we will display these using the production possibility frontier. So in my presentation, I will try to jumble these, just joining them through the PPFs, which I will construct. So to read more on this, you can read Mankiw chapter number 1 and 2 and McConnell chapter 1 and 2. Okay, so let's start by looking at the opportunity cost, which is the value of the best alternative foregone. In other words, opportunity cost is the amount of other products that must be foregone or sacrificed to produce a unit of a product. Simply put, the opportunity cost of an item is what you give up to get that item. And as such, we will display the opportunity cost using the production possibility frontier, and through this same curve, we'll be able to tell whether we are faced with increasing costs or constant costs. So let's go to the production possibility frontier. So the production possibility frontier is a locus of points showing the different combinations of goods and services that can be produced in a full employment, full production economy, where available supplies of resources and technology are fixed. And from this definition, we can therefore make 4 assumptions. Number 1 is that we are dealing with 2 goods. So we can say maybe good X and good Y, or the production of consumer goods or war goods, and so on. So we are only assuming 2 goods. And the reason we're making this assumption is to keep our analysis simple and for us to be able to plot our production frontier in a two-dimensional graph. Then we have the fixed resources, and together the fixed resources and the assumption of fixed technology informs us that we are operating in the short run. So therefore, we also assume that we are in the full employment or productive efficiency mode. So in other words, all the resources used in the production process are fully utilized. Okay, so let's turn to the need for choices. So we see that the production possibility frontier does not only represent opportunity cost, but it also measures the opportunity cost. In short, it demonstrates that, number 1, there is a limit to what you can achieve given the existing institutions, resources, and technology. There is a boundary, and therefore, given all your resources and technology, you cannot produce more than the resources you have. Think of maybe a pot of nshima. You are preparing nshima, and then you received maybe a lot of guests. You will not be able to produce big nshima or a lot of nshima from a given pot that you had initially prepared or reserved for yourself. Therefore, for you to be able to produce more, you will need a bigger pot. So as such, with limited resources and technology, we will not be able to exceed the limit. However, we can produce anything below the limit, but that will mean we will be inefficient. Secondly, every choice made has an opportunity cost. This means that you can get more of something only by giving up some units of the other item. Suppose you had a choice to produce war goods or consumer goods. If you decide to produce more consumer goods, you will need to give up resources needed for the production of war goods channeled to the production of consumer goods. Thirdly, the slope of the production possibility frontier is what we call the marginal rate of transformation. So we will be able to see the marginal rate of transformation from the production possibility frontier. And therefore, we should therefore note that we can distinguish between the constant and the increasing costs. Okay, so with that, let's look at this production possibility frontier where we are displaying increasing opportunity cost. Now you will notice how the PPF is bowed outwards. This is to display increasing opportunity cost. If the PPF is a straight line, then you know that you are dealing with constant opportunity cost. Think of it in this way. So if you look at this part here, for you to produce 1 unit of X, you need to give up some. You need to give up 1 unit of Y. Now, when counting how many units you are giving up, so we count from here. So you add 1 unit of X, you are giving up 1 unit of Y. You are moving from point A to point B. To add another unit of X to go to 2, you give up 2 units of Y from B to C. So you will notice that the opportunity cost has increased. To produce another unit of X, maybe from 2 to 3, you will notice that this time around, you are giving up 3 units of Y. And to produce a 4th unit of X, you give up 4 units of Y. Therefore, the opportunity cost is increasing. Now, from this structure, it should be noted that all points inside the PPF are attainable, but they are inefficient. This is because if you are producing inside the frontier, you are underutilizing the resources. Remember the port example, that if you are producing your items below the limit, it means that you will be inefficient due to the underutilization of the port. Therefore, for you to be efficient, given the resources and the technology, you will have to produce on the production possibility frontier. As such, points A, B, C, D, and E are efficient points and they are attainable. So inside the PPF, you will be able to attain, but you will be inefficient. On the PPF, you will be able to attain and you will be efficient. From here, it should also be noted that points such as W, which lies outside the frontier, are unattainable given the resources and the fixed technology that you have. So the only way we can operate on point W is if we have economic growth. If we see improvement in our technology, if we see an increment in our resources, then we will be able to produce on points outside the PPF, such as point W. Okay. Now, since resources are scarce but wants are unlimited, it means that we need to give up resources in the production of one good for us to increase the production of the other good. Now, what we see then clearly from this is the law of increasing opportunity cost, which states that as the production of a good increases, the opportunity cost of producing an additional item also increases. This is, we illustrated this on the graph when we were showing every additional unit of X we were bringing in. We noticed that we were giving up increasing units of resources needed for the production of good Y. Okay, so this implies that the marginal opportunity cost therefore keeps on rising. As you add one additional unit, you will have to give up more units of the alternative item. So let's now describe allocative efficiency. So with allocative efficiency, we require the expansion of goods output until the marginal benefit is equal to the marginal cost. If the marginal benefit is more than the marginal cost, it means you have room to continue expanding your production. And if the marginal cost is more than the marginal benefit, it calls for you to cut back on your production. Therefore, no resources beyond the point where marginal benefit equal marginal cost should be allocated to the product. So graphically, we see that for allocative efficiency, we are at a point where the marginal benefit, which is usually the demand curve, and the marginal cost on the supply side, we see that the two curves are equal. And at this point, we notice that we have 2, which is captured from the X side, and then 10 on the vertical. So here we see the cost that 2 units will be obtained at a price of 10 or at the cost of 10. And it's at this point where the benefit, the marginal benefit is 10 and the marginal cost is 10. If we go up here, we notice that our marginal cost will be 15 and our marginal benefit will not be as such. So we will see that for consumers, they will be getting less satisfaction, but the consumers, the suppliers, will be facing higher costs. So with this, then it calls for the cutback in the production, and we will have to go back to the point where marginal benefit equals the marginal cost. Let's look at constant opportunity cost. So the straight line production frontier that is downward sloping reflects the constant opportunity cost. The assumptions and the analysis we did earlier still stand here, that points such as E, which lie inside the PPF, are inefficient. They are attainable but inefficient. Points A, B, C, and D are efficient and they are attainable since they are on the production frontier. And the points such as point F, which is outside the production possibility frontier, are unattainable given the resources and the technology. Okay, let's now look at economic growth and see the implication on our production frontier. So society can produce more if technology has improved or more resources are discovered. And even when we have economic institutions which have improved in fulfilling our wants. So given these changes, then we will be able to see the shifting or the changing of positions in the production frontier. Consider quantities of coconuts on the vertical axis and quantity of fish on the horizontal axis. With our production frontier drawn in that manner, where we have the intercepts of 30 and on the vertical and 40 on the horizontal, the changes in technology or the improvement in institutional arrangements or the increment in resources, we will see the production frontier shift out. If we assume that we are at point A, the increase in resources or improvement in technology will shift the PPF outward. And therefore, economic growth results in an outward shift of the production frontier because production possibilities are expanded. And if we move to a different point E, we notice how the improvement has taken place in terms of the output of fish and coconuts. So the economy then can now produce more of everything because there is economic growth. And production, initially at A, where we were producing 20 fish and 25 coconuts, we see that this has improved to 25 fish and 30 coconuts. Okay, so now let's look at the natural technological change, where we have a balanced shift in the production frontier. So if we have an improvement in technology needed in the production of butter as well as the production of guns, and if this is a proportional improvement, we will have a balanced growth. Otherwise, we will have an unbalanced or the biased growth. Let's take a look at an example. Atlantis is a small isolated island in the South Atlantic. The inhabitants grow potatoes and catch fish. The accompanying table below, which I'll show you on the next page, shows the maximum annual output combination of potatoes and fish that can be produced. Obviously, given their limited resources and available technology, as they use more of their resources for potato production, there are fewer resources available for catching fish. Now, from this table, we see that when the quantities of potatoes, the quantities are 1,000, 0 units of fish is produced. And as we reduce the quantities of potatoes, we are noticing an increment in the quantities of fish. The question is, draw a production possibility frontier with potatoes on the horizontal axis and fish on the vertical axis, illustrating the points A all the way to F. In other words, we want to draw a PPF which will show us these points. So you need to be very conscious when drawing your production frontier that the data must be presented, and therefore you look at how the data points are moving. If they are all equidistant, you know that you are dealing with a constant cost, and if they are reducing at an increasing rate, then you know that you are dealing with increasing opportunity cost. So that data in the table should look like this when you plot it. Now, can Atlantis produce 500 pounds of fish and 800 pounds of potatoes? Explain where would this point lie relative to the production possibility frontier. So you go back to your graph and look for 500 pounds of fish and 800 pounds of potatoes. So 500 pounds of fish is this side and 800 pounds of potatoes is this side. So if we draw a straight line from 500 here, we go all the way to where 800 is, we will notice that this point will lie outside the production frontier. Therefore, it means that Atlantis will not be able to produce at that point given the resources. What that means is that Atlantis cannot produce 500 pounds of fish and 800 pounds of potatoes. If it produces 500 pounds of fish, the most potatoes it can produce is 600 pounds. This point then would lie outside the frontier. So if it produces 500, it means of fish, the best it can produce of potatoes will be 600. The next question is what is the opportunity cost of increasing the annual output of potatoes from 600 to 800? So for us to increase the production of that's potatoes, the production of potatoes from 600 to 800, so we are here. So if we are to increase the production of potatoes from 600 to 800, so to 800, it means that we will have to give up. So for us to cover this distance, we will have to give up this distance. So in covering this, we give up that distance, meaning our opportunity cost will be 200. We'll be giving up 200, that's 500 minus 300. So for us to increase production, that's from 600 to 800, we will have to give up 200 units of fish. Okay, so let's go back to our analysis, our questions. So the opportunity cost of increasing output from 600 to 800 pounds of potatoes is 200 pounds of fish. So remember that the opportunity cost of an item is measured using units of the other items. So you can't say the opportunity cost is 200. You have to add fish, because what you are giving up is fish for you to produce potatoes. Therefore, the opportunity cost will be 200 pounds of fish. Okay, we are asked again here, what is the opportunity cost of increasing the annual output of potatoes from 200 to 400 pounds? So we go back to our graph. We are increasing potato production from 200 to 400 pounds. For us to make this movement, we will notice that we are moving from point E to point D. So we are giving up 650 minus 600, which will be 50 pounds of fish. Therefore, the opportunity cost of increasing potato production from 200 to 400 is 50 pounds of fish. So if we were to increase from 200 to 400, we will be giving up 50 units. Okay. So the opportunity cost of increasing output from 200 to 400 pounds of potatoes is 50 pounds of fish. Okay, can you explain why the answers to part C and D are not the same, and what does this imply about the slope of the production possibility frontier? So for you to get that, the answer to part C and D imply that the more potatoes Atlantis produces, the higher the opportunity cost becomes. For instance, as you grow more and more potatoes, you have to use less and less suitable land to do so. Okay, so with that, then we conclude that as a result, you have to divert increasingly more resources away from fishing as you grow more potatoes, meaning that you can produce increasingly less fish. And with that, it implies that the production possibility frontier will become steeper the further you move along it to the right. And this means that the production frontier is bulged outwards. So mathematicians call this the concave. So we will call the bulged shape, which is outward, as concave, and the one that is bulged inwards, like the indifference curve, as convex. Okay, so thank you very much for watching. I will see you in Unit 5. If you have questions, please send an email to muauelias@gmail.com.